Find where the function is increasing or decreasing. All right, so this is what I'm going to do. I'm going to find where the derivative is positive because when the derivative is positive, that's increasing. When the derivative is negative, that's decreasing. What I need to do first is I need to find my critical points. Why? Because the critical points tells me where my derivative is 0. Once I get zeros, I can kind of break it up into intervals and figure out which ones are positive, which ones are negative, take it from there. So I have to take the derivative of this guy. So negative, bring that 4 down, turn x to the 4th into x to the 3rd. Multiply that 2 to 3, x squared becomes x to the 1st, and the derivative of negative 3 is nothing. I don't know why it took me so long to figure that out. Now, in order to find the critical points, I need to set my derivative equal to 0. While I'm at it, I'm going to factor negative 2x out. Okay, because 2 is divisible by these guys, the negative because I don't like my leading coefficient being negative, and there's an x in common with both. So when I divide out a negative 2 from negative 4, I get 2. And when I take an x away from x cubed, I get x squared. When I divide a negative 2 from regular 6, I get negative 3, and that's it. Now, the zero product property says that if I have 0 equaling two numbers multiplied together, or two factors rather multiplied together, I take each factor, set it equal to 0. So I have negative 2x equal to 0, and I have 2x squared minus 3 equal to 0. Divide both sides by negative 2, and one of my critical points is 0. Easy enough. Let's add 3 to both sides. Divide by 2, and x squared equals 3 over 2. Now be very, very, very careful. I have to solve for x, and the way I do that is by taking the square root. Do not forget your positive or negative. It happens all the time. So 2 other critical points, not 1, but 2 other critical points are going to be positive or negative 3 over 2. So 0, negative 3 over 2, and positive 3 over 2 are where my original function is going to have a slope of 0. So neither increasing nor decreasing. Now what I'm going to make next is something called a sign table or a sign graph or a sign chart. Now S-I-G-N, not S-I-N-E. Don't get excited. All right. I'm going to put my x values for critical points right here. The negative 3 over 2, 0, and square root of 3 over 2. Not negative, but negative square root of 3 over 2. I'm putting those there in order. What I'm going to do is I'm going to choose values in between these numbers, and bigger than and smaller than, and plug them into my derivative to see if those values give me an interval that's positive or negative. If it's positive, that tells me that everything between here and here, or everything between here and here, or everything there is positive or increasing. And if it's negative, decreasing. So I need to pick numbers that are not exactly these numbers. Now, if you're wondering, well, why can't you just pick these numbers? Well, if I take these numbers and plug them into the derivative, I get 0, which kind of defeats the purpose. The 0 tells me that that's where a change probably occurs in increasing to decreasing. So square root of 3 over 2 is like taking the square root of 1.5. So that's going to be bigger than 1, but not that big. So I can use 1 and negative 1 as potential numbers to plug in. I'll use 10 and negative 10 because why not exaggerate things? And I plug these into my derivatives. All right, so let's start out with negative 10. So y prime of negative 10 is going to be this guy right here, negative 4 times negative 10 cubed plus 6 times negative 10. Now, I'm not going to overthink this. I'm not even going to do any math. Negative 10 cubed is negative 1,000. You multiply that to negative 4 and you get 4,000. 4,000 minus 60 is going to be a huge number. But the most important thing is that it's going to be positive, which tells me that when I plug in negative 10, it's increasing. So this is why I call it a sine table or a sine chart, because by plugging in negative 10, I know everything from negative infinity to negative square root of 3 over 2 is going to be an increasing part of this function. Now, if you're like, well, that's easy, I'll just get negative, positive, negative. I don't know. Probably, but I don't know. So let's find out what y prime of negative 1 is. Okay, that's going to be negative 4 times negative 1 cubed plus 6 times negative 1. Negative 1 times itself 3 times is going to be negative 1. Negative 1 times negative 4 is positive 4. Positive 4 minus 6 is negative 2, which tells me that between negative square root of 3 over 2 and 0 is decreasing. Almost there. Y prime of regular 1 is going to be negative 4 times 1 to the third plus 6 times 1. 1 to the third is 1. Negative 4 times it is negative 4. Negative 4 plus 6 is positive. So that tells me that between 0 and root 3 over 2 is going to be an increasing function. Last but not least, let's plug in 10. 10 tells me what's happening after the square root of 3 over 2. So negative 4 times 1,000, or, well, 10 cubed, which becomes 1,000, plus 6 times 10 is going to be 1,000 times negative 4, which is negative 4,000. Negative 4,000 plus 60 is still going to be negative, so it stays negative. Boom. All right, now let's get rid of, I hate it, but we need to get rid of this to give ourselves some space. Okay? This is now telling me that everything is increasing. Everything is increasing on the intervals negative infinity to negative root 3 over 2. Also, it's increasing on the intervals 0 to root 3 over 2. And it's decreasing between negative root 3 over 2 to 0 and root 3 over 2 to infinity. So there you have it. Very, 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 very busy problem. Lots to do. But without graphing, I was able to figure out where stuff is increasing and decreasing.